everyone. Thanks for joining today's Isaac ROS office hours. I hope you can hear me. If you can, could you please leave a comment and just let me know that you can hear me all right? So thank you for joining again. Today, we are going to be talking about Isaac ROS object detection. We've also already had a question on the post that we had made regarding this office hours. So thank you to whoever made that question, and I will be taking it up in today's during today's office hours as well. Okay, great. Good to know you can hear me loud and clear. Let's get started. I'm going to share my screen. And I hope you can see that as well. Okay. So today we're going to be talking a little bit about just object detection in general, how it is using the YOLOv8 model. We'll talk a little bit about YOLOv8 as well. But mainly I'm going to be talking about how to create a nitrous accelerated Isaac ROS node from any object detection model of your choice. The example we are taking today is just YOLOv8, but what you learned today you should be able to extend it to any custom model of your choice as well. A little bit about what we talked about on the last Isaac ROS office hours. My colleague Raffaello talked about Isaac ROS depth segmentation, and he talked particularly about the by3D model architecture. This is a node we have for proximity segmentation and how the Isaac ROS by3D model works. I believe he also showed how to actually install it and how to use it through the Isaac ROS development container. If this is something you watched and learned something from it, that's awesome. If not, I've shared the QR code here on this slide and the link to the recording as well. Please feel free to go check that out. And what we try to do is every other week, we host the Isaac ROS office hours, and we try to take up one package or one particular perception node that the Isaac ROS collection offers per office hours. Of course, this particular office hours is not meant to just talk about that particular model or package or node, but it's more of just a little bit that we can share so that you learn more. But feel free to ask questions related to Isaac ROS in general, like any Isaac ROS questions you may have about installation, setting up, benchmarking, just how to use any other package as well. You can start posting questions related to that in the chat as well. Okay, so today's agenda, as I mentioned earlier, would be about general object detection with the YOLOv8 model. Particularly, Isaac ROS offers a YOLOv8 sample as well as a model called DetectNet for detecting people in images. And the beauty about these particular packages or how they differ from a standard ROS2 package is that these are accelerated to run on NVIDIA GPUs and on the Jetson platform. So these are optimized to give you the best performance on these particular platforms through something called Nitrous. Now, Nitrous is something I'll get into a little bit. I'll share an overview in today's office hours. But we have done a more detailed office hours a couple of weeks or maybe months ago called CUDA with Nitrous. So later in the slides today, I'll share a link to where you can access those office hours from as well. And that would be the right place to learn a little more in depth about Nitrous. And the main crux, I guess, of today's office hours is how to nitrosify your custom nodes. So if you've written already a standard ROS2 wrapper for, let's say, YOLOv8, how would you make that Nitrous compliant or Nitrous capable such that it can work in that accelerated way with all the other Isaac ROS packages? And then, of course, I'm going to not spend too much time just talking about this, but give a majority of the time to questions and answers. We'll also pick them up throughout the discussion as we go. So you can start posting them in the chat. I'll pick them up whenever relevant or towards the end. I also have a colleague who will be answering questions on the chat and sharing some links to just documentation wherever important. Okay, these are some relevant resources to today's particular topic. I realize that I am blocking a QR code at the bottom, so let me change the layout a little bit. Let's see. Okay, that's better. So the first QR code over here is links to the Isaac ROS webinar series page. So once you go here, you'll find a lot of content about 10 or more webinars catered to a particular Isaac ROS topic. But the two that I think are relevant to today's topic are first, accelerate YOLOv5 and custom AI models, and the second is use your own CUDA ROS node. So both of these talk a little bit about what Nitrous is, and how you can make your nodes Nitrous compliant to use with other Isaac ROS nodes. But you can also go there and register and there's a whole lot of different webinars you can view on demand. The second QR code is to a technical blog that I wrote specifically about Nitrous and again, what it is, what advantages do you get if you use it in your ROS pipelines, and how to make your own custom models or your own custom ROS nodes. So that particular blog actually talks a little bit about the YOLOv8 sample. And today's office hours will kind of elaborate a little more on how to actually develop if you are interested in doing that. And then the last QR code is the last Isaac ROS office hours that we have, or maybe 2 office hours ago, where we talked about CUDA with Nitrous, specifically Nitrous and its advantages. Again, how does it exactly work? So that would be the right link to go and watch that office hours as well. So one new thing that we've kind of started recently is the smallest QR code at the bottom of this slide. It links to the Isaac ROS office hours questions. So that is specifically for office hours like today's, where let's say you posted a question and we tried answering it, or it could have been answered in more detail. That is where you would go and post your question and kind of just interact with us in a more forum-like way, where we can get more details from you based on what your question is, what your setup is, and we can provide our guidance in the best way possible. So that is a QR code that I think I've shared through most slides of today's presentation. And it would be the best place for you to get started with questions geared to specifically the Isaac ROS office hours. Okay, cool. So let's get started a little bit with today's agenda, specifically object detection with Isaac ROS. So this is just a very overview, like preview kind of slide about what Isaac ROS offers when it comes to object detection. So it offers 2 GPU accelerated packages, ROS2 packages, that use 2 different models. So the first is DetectNet and the second is YOLOv8. Both of these samples are Nitrous accelerated. What Nitrous is something you may have seen previously through our webinars or our blogs or office hours. If not, on the next slide, I'm going to give you an overview about what it is. But essentially, it is something that accelerates and optimizes your models for best performance on NVIDIA GPUs and on the Jetson platform as well. So with these 2 models, again, what you will get is specifically object bounding boxes, which is to say just information about if an object is present in an image, and if so, where is it present in that image? So just the localization. What these packages do not give you, though, is like a segmentation mask, or the actual pixel information about where the object is in the image, because these are not segmentation models. So again, if an image mask or an object mask in the image is what you're interested in, then I would encourage you to instead look at Isaac ROS image segmentation, because we have some models there that do segmentation. But these specifically are for when you just want 2D bounding boxes around objects in your image. Both of these models, and specifically like all the Isaac ROS packages currently, have been tested for optimal performance on ROS2 Humble, on the Jetson and just NVIDIA GPUs. But that does not mean that it's limited to being used with only ROS2 Humble nodes. Through something called the ROS bridge and the Nitrous bridge, you can also kind of bring your ROS1 nodes or other versions of ROS2 to use with these Isaac ROS nodes. Okay, so a quick overview about Nitrous, or NVIDIA Isaac Transport for ROS. So this is NVIDIA's implementation of 2 hardware acceleration features that were implemented with ROS2 Humble. The first is called type adaptation, and the second is called type negotiation. So type adaptation and negotiation let different ROS nodes in a particular pipeline. So if you have, let's say, an image resize node and then an inference node and something that decodes your output, if this is maybe your pipeline of 3 ROS nodes, then without Nitrous acceleration, what's going to happen is, I think, look at the top half of the GIF over here. What happens is that data is communicated multiple times between the CPU and the GPU. And this is obviously going to result in a little bit of latency and just overhead in performance. Ideally, what you want to happen is the bottom of the GIF over here, once the data comes in through a standard ROS message onto the CPU, If that can be communicated to the GPU just once, and then all compute and all of your ROS intensive tasks that are happening could just happen on the GPU, then you would be saving a lot of time in terms of by kind of reducing those copies between the CPU and the GPU. So that is exactly what Nitrous enables. The bottom of the GIF over here is a pipeline that's using Nitrous, or that can communicate through your um, through the ROS layer, but on the GPU. So what you want is to be able to nitrosify all your ROS nodes to run in this particular way, right? So what I'm going to talk a little bit about is first how to ROSify a node, like without using Nitrous or any specific hardware acceleration, how you can just convert your particular model into using ROS. But that is something most of you might be familiar with or may have done in the past. So I'm going to focus more on this Nitrous part of it. How can you make your node use Nitrous or communicate through type adaptation and type negotiation? One important thing to note here is that let's say you're using 2 or 3 Isaac ROS nodes in your pipeline. So they are already Nitrous accelerated. And you bring your own node to the pipeline, which is not, right? This does not mean that your node will not be able to communicate with the other Isaac ROS nodes. And the reason is that the ROS framework maintains some sort of compatibility with legacy nodes. So without any effort or any additional code, your node will still be able to communicate with the Isaac ROS nodes. Just that it will kind of be copying data between the CPU and the GPU. And this is why, like at that point, to kind of upgrade your node to speed up acceleration overall of the pipeline, you would want to convert it to a Nitrous node. Eventually, I will introduce a concept called CUDA with Nitrous, and this includes two things: the managed Nitrous publisher and the managed Nitrous subscriber. And these are kind of what enable you. It's just a different way of writing your C++ ROS nodes, but they will actually enable you to use this particular hardware acceleration. I see a question in the chat. I think we can take it up at this point and then continue. It says, thanks for your question. It says, are there any benefits to running the camera image topic through the Argus cam instead of straight into a resize node? Good question. And for those who may not know, like just for context, we do have an Isaac ROS Argus package. So I think this question relates to using that node and passing images through that package instead of straight into the resize node. So yes, the benefit here is that the Isaac ROS Argus camera package is also Nitrous accelerated, which is to say that once the image topic or the ROS image topic comes in, it will directly put that onto the GPU. And then that image handle is something that will be passed within the GPU and then to the resize node or whatever your cropping node, whatever you need to do. And once it's already done that way, it's already in GPU land. So it's like just communicating through the multiple Isaac ROS packages without going back to the CPU. So that is the benefit. And I believe one way you can actually test this is having your pipeline with the Isaac ROS Argus Cam node, and then the same pipeline but without that node, and pass both through Isaac ROS benchmark. I'll share a link to that later as well. But you can actually see the gains, the performance gain through while using the Argus Cam versus without using the Argus Cam package. Hope that answers your question. Okay, so let's move on to actually performing object detection with the YOLOv8 model. So most of you, I mean, YOLOv8 is one of the most popular object detection models. So most of you have used this at some point already. But what's important to know here is to be able to figure out which particular version of YOLOv8 you want to use. So there are multiple sizes, which I've shared in the table over here. It goes from the smallest, which is YOLOv8N or nano, and then you have the small, medium, large, and the extra large. Of course, as your model size grows like larger in terms of parameters, your accuracy increases. So your model will be able to detect things with just a higher accuracy. But it is a trade-off between accuracy and speed. So your model speed or your inference speed does become slower with the larger models. But what you would want to pick is an ideal mix, I guess, of like, you'd want to consider what device you're running this on. If it is a smaller device, an edge device, resource constrained, then maybe the nano or the YOLOv8 small model is appropriate. But in cases where you require more accurate detections, you'd want to take the bigger models. Now, any of these YOLOv8 models, if you take them just straight off the Ultralytics project, then out of the box, they can perform object detection for 80 object classes. And I think the example that we have, the Isaac ROS YOLOv8 sample, also just performs detection on those 80 object classes. Now, what you have to do is the images that just at the bottom of the table over here, I'm realizing it may be a little small. But what's important to do is that once you've downloaded the model of your choice from the Ultralytics project, you have to first export it to Onyx. How to do that is all given on the Ultralytics repo, so that's pretty convenient. But once you have it in the Onyx format, you can upload it to Netron. Netron, for those of you who haven't used it before, is a place where you can, once you put your Onyx model, you can view the entire model and the different layers and what's happening on the input and the output side. Why this is important is that the name of the input, so on this slide here on the left, it's very small, but it says images. And there's also the input size that's given here, which is 1 by 3 by 640 by 640. So that's just the image size, a 640 by 640 RGB image. And it's important to note the same on the output side as well, the name, which says output 0 here, and the output size, because these are things that you eventually use with the Isaac ROS pipeline for inference and on the image encoding and decoding side. So I think that's what's important here. Like once you have your model, knowing some of the input and the output information, and mainly making a good choice about which model it is that you want to use. Okay, moving on. I do see another question, so I think we can pick that up before starting with this slide. It says, I'm on my first steps with Isaac, but I have a question. Can I run Isaac on my notebook? I'm using an R7 with 24 GB RAM. Got it. Okay. So Isaac, I'm assuming this means Isaac Sim. If it is Isaac ROS that you're talking about, then yes, you should be able to run it on any NVIDIA GPU. If it's Isaac simulation that you're talking about, and could you please clarify? But for Isaac Sim, I believe we have a set of, I am not too sure about the like system requirements myself, but we have probably just the first page of the Isaac Sim documentation where you will be able to see what are the minimum requirements for running, what are the ideal requirements, and what are like really good where you can render, absolute best quality environments. So I would encourage you to look at that. If it's Isaac ROS, then yes, it will run on the setup you have right now. Okay, thank you for that question. So now let's get a little bit into the Isaac ROS YOLOv8 package specifically and object detection with this. The QR code I've shared here is to the repo, and this is just a sample image of what the output looks like on an RViz or RQT window. In this case, the point of this sample is to show you how to bring any custom or your own model and how to make it Isaac ROS by nitrosifying it or by adding some lines of code to it to make it more nitrous capable to use with other Isaac ROS nodes as well. Now, in any object detection pipeline, there are three main steps that we talk about. First is the input encoding, second is the inference, and third is the decoding step. I think I'll go into a little bit more detail about each of these, but focus mainly on the decoding step because that is where you will be writing your own notes for your own tasks. Okay, we got clarification in the chat about, yes, they were asking about Isaac Sim and if they can run Isaac Sim on their particular setup. For Isaac Sim, Marcus, I would encourage you to go look at the documentation for Isaac Sim because you'll get the minimum requirements there as well. And of course, even their performance would vary based on your setup. One more thing I think is good to share at this point is that every alternate week, we have the Isaac Sim office hours as well as Isaac ROS. So this Wednesday, we had Isaac ROS. Next Wednesday or the Wednesday after that, we would probably have Isaac Sim office hours as well. So that's, again, a good place for you to join and ask your simulation and Isaac Sim related questions. It's a very similar format wherein maybe they take a topic of the day, but then you can ask all the questions that you have related and people will answer them on the spot. So thank you for your question. Moving on to the Isaac ROS DNN image encoder. So this is the first step of your object detection pipeline. And what's great is that Isaac ROS already has a pre-existing image encoding step. So any pipeline where where your model is expecting an image input, you can just use this particular package just out of the box. What it does is that it pre-processes your images and converts it into tensors. And then these tensors are used by the inference node, the Isaac ROS inference node. So at this point, things are already happening all on the GPU, which is why we say it's already nitrous accelerated. And when I mentioned, oh, sorry, I think my slide moved. When I mentioned that it's important to note the input and output dimensions and names through Netron in an earlier step, this is why, because the image encoder node takes parameters that include things like the image size, which in this example could be 640 by 640. What is the name that the network expects in the input? So that would be images. So these are the kind of parameters that you would be using at this step. What I have in the image is just a small example of what it would look like. So your image would first go into this DNN image encoder node. By the way, the DNN stands for deep neural networks. So any model where image input is expected, you can use this. However, one thing to note is that let's say your model is like a language model and expects text encodings on the input side. You cannot use the image encoder over there. In that case, you'd have to create your own that can take textual input. But for most image cases, this would just work out of the box. Okay, moving on to the inference part of the pipeline. So this is kind of like the brain, or where the actual inference is happening from image to tensor output or object detection tensors. The Isaac ROS particularly provides two both nitrous accelerated nodes for inference, and one of them is called the TensorRT node. The second is called the Triton node. Now, for the YOLOv8 sample, we only, I think, provide a launch file for the TensorRT node, but it's not that far, or it's not too challenging to write your own launch file for if you want to use the Triton node as well. And we did get a question about like what's the difference between these two nodes. I think I'll address that question together with the other questions we got on that post. But here, what's important to know is that your inference node sits between the encoding and the decoding step. And what you do is provide your trained model at this step to the TensorRT node. So that can come in the form of an ONNX file, or it can come as a PyTorch or a TensorFlow model as well, or a TensorRT engine file. And based on what you're passing, you would use either the TensorRT node or the Triton node. Now, the output tensors are just passed as a tensor list message to the decoder node, which now the decoder node is, of course, the next step is what you would implement by yourself in this case, or in the case of your own custom model. So it's important to know how your data is organized in the output tensor as well. But to the TensorRT node specifically, there are some parameters that you can give. And I have not listed all of them here, but the table towards the bottom of the slide is just an example of what some of these parameters look like. So the first two rather, the model file path and the engine file path is where you would specify your ONNX model. So that just is the location of where you've put your ONNX model. The first time you run the TensorRT node, it is going to generate a TensorRT engine file from the ONNX file. And that step does take a little bit of time, maybe like a minute or up to 2 minutes. But subsequently, once you already have that TensorRT engine file, every next run, you can just point through the engine file path parameter to where you've stored that engine file. And then it should be much faster after that because it just loads the engine file. Now the next three parameters, so input tensor names, input tensor formats, and input binding names, these are all information that I believe you can get just from Netron. And you would pass, so in that, if you remember, I had said images is what the input name was in the Netron image. That is something you would just pass over here. The tensor format would be your, RGB, how many number of channels, that kind of information. And of course, all three of these parameters are exactly the same on the output side as well. So you have the output tensor names, output tensor formats, and output binding names. Now, the force engine update parameter is something that if you set it to true, then what it would do is every time, even if it does see an engine file present, it will generate a new engine file from the ONNX file. So that adds a little bit of time to the whole pipeline. Of course, if this is set to false, and if you already have an engine file available, then it would just use that pre-existing engine file. enable FP16 is another question that we got. So we will get more into depth about this parameter later. But if your Onyx file, if you want the TensorRT engine file generated from your Onyx file to be FP16 optimized, then you would set this to true. If not, and the default is FP32 optimization. So setting this to true just will give you a slightly faster engine and hence better performance when it comes to inference. And then the last parameter, DLA core. So some of the NVIDIA hardware, especially the Jetson platform, for example, has something called DLAs or deep learning accelerators. So these are specialized hardware to run deep learning models, and it can run some particular layers of most deep learning models. So if you know that your custom model has been, or any model that you're using in this case, can run on the DLA, then it's a good idea to set this parameter to true. And in the DLA core, I believe you would specify the number of like which DLA, like 0, 1, which one you want to run it on, because that way your model will run on the DLA and it'll keep your GPU available for other tasks. So that is how you can kind of offload from the GPU to this kind of specialized hardware. And of course, there are some layers that do not run on the DLA, I believe. So in that case, it just falls back to the GPU. So it will still run without failing. But the kind of performance you get depends on a combination of like what percentage is running on the DLA and what percentage is running on the GPU. Okay, so that's a little bit more about the TensorRT node. Let's see. Okay, so now this is from this point on, we're just going to talk about the decoding side of the pipeline. And before we actually get into how Isaac ROS decodes it or how to make your own Isaac ROS node for YOLOv8 decoding, let's just talk about what the YOLOv8 output looks like in general. So the tensors that are coming from the Isaac ROS TensorRT node have a size of 8400. So what the 84, that second dimension over here, is just the number of classes, which is 80 plus 4. And that plus 4 corresponds to the bounding box x and y coordinates and the height and the width of the bounding box. So the 80 class, or rather that first 80 dimension, one corresponding to each class, is just a probability of that class being the output of that particular detected object. So let's say, for example, if you had a model that was detecting maybe just 10 classes, then that second dimension of yours in the output tensor would be 14, because the first 10 would be the 10 probabilities corresponding to each class, and then the next 4 would be the bounding box information. So that is how you kind of understand or parse that second dimension of 84 in this case. The 8400 is, of course, this is a little more, I guess, complex and not exactly the scope of today's office hours, but you have different detection heads within your model that are detecting output at different scales in the image. So smaller things or a smaller scale would give its own set of detections. Similarly, a larger scale would. And in the case of this particular model, just out of the box, you have an 80 by 80, a 40 by 40, and a 20 by 20 scale at which objects are detected. So if you just sum up these different scales, you're going to get that number of 8400. The most, I think, important thing to know over here is something called NMS, or non-maximum suppression. So this is a post-processing technique that's done in all object detection pipelines to be able to condense, or rather to eliminate duplicate or redundant detections. So what I mean by that is a little more clear in the image over here at the bottom. So I think for the person, you have multiple bounding boxes that are potentially all correct. Like these are all candidate bounding boxes. But we want to be able to find the highest probability or the best fit. And that is where the NMS post-processing step comes into the picture. It does this sort of filtering for you, and the algorithm will give you the best fit or the highest probability bounding box for that particular object. Let's see. So this is the most important step, I think, in knowing how the output tensor is going to look like when you're using your custom models, because based on that, you will write your decoding logic on the decoding side. And then writing the logic is the first step. Second step, if you want to use it with ROS, is to bring it into the ROS2 world by writing, a publisher, a subscriber, and then using the logic in that form. And then the third step is actually making it nitrous capable when you're using it with other Isaac ROS nodes. So let's see how to do that. Right. So in this step, I'm assuming that we know how to write at this point the YOLOv8 decoder. So you know how to implement that decoding step into whatever, like Python or C++, whatever you may be using. Again, note that if you want to use it with Nitrous, then it has to be a C++ ROS2 node, at the moment at least. Right. So let's say you have already written that ROS2 node that does decoding, but it's not an Isaac ROS node yet, or it does not work with Nitrous on the NVIDIA architecture or platform yet, right? So you will use something called, broadly we call it CUDA with Nitrous, but within it there are two important, I think, concepts. One is called the managed Nitrous publisher, and one is the managed Nitrous subscriber. What these two do is, if you look at the image at the top over here, let's say in purple, it's just the your CUDA ROS2 node that you've written to do decoding in this case. But at the moment, it does not know the Nitrous typed messages that are being communicated between the other Nitrous nodes. So it needs a way to be able to communicate, first of all, on the GPU, and then second of all, in the Nitrous typed messages in that format. So what you can do is you can just kind of imagine like plugging in or inserting the managed Nitrous subscriber um, into your node, and then it will be able to take Nitrous typed output tensors from the TensorRT node, and it'll be able to apply that same logic that you've already written. And now, if you want to further publish that information, instead of publishing it as a standard ROS2 message, what you want to do is publish it as a Nitrous type message, so that other Nitrous nodes can just pick it up on the GPU without any copies here happening with the CPU and back. If you look at the image towards the bottom, I'm not sure how big the image is, but in green is just your custom decoder node that you've written, normal ROS2 node with the wrapper around your logic. But in the blue, you see the managed Nitrous subscriber. So this subscriber is actually letting you just take the output tensors from the Isaac ROS TensorRT inference node, perform whatever logic, and you have two options at this point. You can either use a normal ROS2 publisher to publish your results, or you can also use the managed Nitrous publisher. And then that will allow you to Nitrous wrap the message that you're passing on to the next node. So let's see. One important thing to note here is that if your node, like in the top image, if we look at the purple part that says my CUDA node, if that node is still not Nitrous capable, it's fine. It will still work with the rest of the pipeline, and it will work with other Isaac ROS nodes. Just that it will have some data copies happening between the CPU and the GPU. And so you will observe a little bit of latency compared to having everything just running on the GPU. Okay, so let's see. Again, if you have any questions, please feel free to drop them in the chat. Or if your question is a little more, sometimes we need more information to figure out like what's going on in your system, why things aren't working. If things aren't working, then the best place to share more log files and information about your setup would be at the little link and the QR code that I've shared at the bottom of the slide. We pick those questions up every week, and I think that is a better place to give a more detailed question about whatever your particular Isaac ROS question is. Okay, I think this is one of the most interesting slides because it shows how easy or straightforward it is to make your node Nitrous compliant, Nitrous capable. So at the bottom over here, I've included a small code snippet. You'll see this, or the entire code is available on the Isaac ROS YOLOv8 repository. But this is how to actually use the managed Nitrous subscriber. It's just a few lines of code over here, but through this, it may be too small, but I hope you can see it says the Nitrous tensor list NCHW. That's just a Nitrous message type. So this is you telling the code that instead of listening in on a normal ROS topic as a subscriber and just listening to the normal ROS message, I want you to listen to the Nitrous tensor list message instead. So this is how it knows to pick up that information directly from the GPU. And then we've also shown how to just create the normal publisher here for a detection 2D array type. But even at that step, you can instead use the managed Nitrous publisher and make sure you're publishing also on Nitrous. Now, the good thing here is that if, for example, after the decoding step, let's say you have a visualizer, and you want to use that to either pass image messages to RViz or to RQT, those nodes, like the RViz node, for example, would not be nitrous accelerated, let's say. So the good thing is that you can publish a normal ROS2 message as well from your node and have it communicate with those legacy non-nitrous nodes, or choose to have it nitrous typed, and then it will communicate with further Isaac ROS nodes that may be ahead in your pipeline. If you can see, and if you have any questions about the little code, feel free to put it in the chat. What's important to know here is that it's something called nitrous views that let you use, that let you subscribe to and just get the tensor shape, for example, the tensor name, things like that, coming from the TensorRT node. And it's as easy as deciding on what topic you want to subscribe and publish, and then instead of the standard ROS types, publisher subscriber, you would use the nitrous type. And again, for this node, for the Isaac ROS YOLOv8 decoder node, we have some parameters like the NMS threshold. NMS is the post-processing step that we talked about, and confidence threshold as well, to specify that detections below a certain confidence should not be considered. Okay. I got some feedback saying my camera feed is stopping once in a while. I hope it's gotten better since then. Okay. So this is an overview about how all of it looks together, the Isaac ROS YOLOv8 pipeline for object detection. So first you have the Isaac ROS image encoder node that, again, you can just use out of the box for image data. And then you can pass on the encoded input tensors to the TensorRT node or to the Triton node. Both are Isaac ROS supported inference nodes. At this step, you pass your Onyx model, or actually your model can be of another format as well. We'll talk about that in a minute. And then you have your decoding logic, where you implement the decoder as a standard ROS2 node, or you add the managed nitrous publisher subscriber to make it nitrous capable, to keep all the data on the GPU. And then you pass that to a potential like just visualization node, at which point it can either be converted back to a ROS2 standard message or be kept as a nitrous type message. I see a question on the chat. Sharing it here. Okay. It says, is nitrous built on the previous DDS code base for drive? So with nitrous, or rather with Isaac ROS, you can use any of the ROS middleware. So DDS, but it's not based on, as far as I know, on the code base for drive. That is a different thing. I imagine, okay, the question is extended. Do I imagine it is intended to run on edge devices? That's right. Isaac ROS is intended, well, edge devices in terms of the NVIDIA Jetson, but also can run on NVIDIA GPUs. But I think a major use case would be if you have a robotics pipeline and you have your own robot like hardware, but you want to be able to run just the perception packages out of the box. Like you don't want to implement your own perception packages. That's where Isaac ROS steps in, because you get a whole collection of perception tasks for robotics, and you get to use them optimized on that particular hardware. Okay, I'm seeing another question, sharing that on the screen. Is nitrous utilizing mainly C++, or can we utilize Python as well to write nitrous publisher or subscribers? Good question. At the moment, it utilizes mainly C++. So if you've written your decoder in Python, we don't currently support writing the managed nitrous publisher and subscriber with that. But also, since this is mainly done for performance optimization, I think it makes sense anyway to have it all in C++. The sample we provide, the Isaac ROS YOLOv8 sample, is a C++ ROS2 node, and it uses the managed nitrous subscriber. Good question. Thank you for that. Okay, so we were at the overview of the pipeline. Okay, I'm nearing the end of my slides here. Just some last minute important things that I wanted to share. The first is the link that I've been sharing throughout the slides to the Isaac ROS Office Hours questions. A good place to go and post your questions from today or from any of the other Isaac ROS Office Hours you may have attended. The second is to the Isaac ROS Developer Forum. So over there, you can view questions from other developers. You can also view some important announcements about new features that we're coming up with, or other Isaac ROS webinars and office hours that we'll be conducting. So that's just a good place to go and get like all news and updates about Isaac ROS. And the final link, the final QR code on this slide is to the Isaac ROS official website. So that's a good place to get started and see the whole story and what we offer, what are the multiple different packages you can use, just things like that. Okay. I'm seeing another question in the chat. Let me go ahead and share it on the screen. It says, do we need to have multiple computing devices on the robot? Shouldn't we learn also the NVIDIA Mellanox networking? So I think Isaac ROS is something that, I mean, whether you're running it on a single compute device or multiple computing devices, as long as it can communicate at the ROS level, I believe this is not something I have tried myself, but I think if you could maybe add all of them to the same ROS domain ID or something like that, then they will still be able to communicate with each other. This is again at the ROS level, like through the ROS topics and services and messages. Another point here is that if you are using Isaac Sim as well, so if you're doing like hardware in loop setup with Isaac Sim publishing some input, and then you performing inference with Isaac ROS, maybe giving output back to Isaac Sim, all of that can be done through, there is a ROS2 bridge on Isaac Sim as well. So that's how you would communicate in that particular case. All good questions. I see one more. If I use darknet ROS package with YOLO in Isaac Sim like pub and sub, I am not sure I understand the question, but I think, or this is how I'm interpreting the question right now. It's saying that if you have, let's say, Isaac ROS YOLOv8 running, and then you want to use it with a non-nitrous package, maybe your own, how would that communicate? So yes, in that case, you can use like the standard pub and sub for ROS2. It'll work just fine. If you want to kind of step it up and make your ROS package also nitrous accelerated or like accelerated to run on the GPU or on the Jetson, then you would have to look into nitrousifying it. So using the nitrous pub and sub in that case. Okay, one last thing that I wanted to share. This is something I'm very excited about myself. It's NVIDIA GTC coming up in a month, March 17th to March 21st. So this is going to be a great place to just learn about all the cutting edge things happening in AI, accelerated computing, robotics. The first QR code here is to where you can register for the event. We have it both this year in person and virtually. I believe virtual registration still gives you access to everything, maybe everything other than the hands-on sessions that we'll be having in person. And then the second link that I've shared here is to the robotics specific sessions. And a little more about what that is on the left side of the slide over here. So this is just a collection of some of the robotics talks that we're going to have. And also towards the bottom, there are some DLI training labs. So DLI stands for Deep Learning Institute Training Labs. These are more technical, like hands-on sessions where you'll have an instructor or two and a class of maybe 50 to 100 participants. And most participants they'll have their own setup and they kind of can follow with what the instructor is doing. It'll be a very hands-on way of understanding Isaac ROS, Isaac simulation, generative AI on Jetson, things like that. So please register. And I think it's a great opportunity to learn, to network, and to just hear from some of the greatest minds in what's happening in the AI and robotics world right now. Okay, so that's about it. What I wanted to share about Isaac ROS YOLOv8, object detection, and how to write your own nitrous nodes. I'm going to stop sharing my screen for a minute. And we had a couple of questions related to Isaac ROS YOLOv8. So I'm going to share those questions. Let's see. This should be the one. Yes. Okay. I see another question in the chat. It says, can we watch robotics session for free or we have to pay? So I think if you register virtually, it's for free, but you do not have access to the hands-on sessions that I talked about, the Deep Learning Institute sessions. But the talks and the actual speaker-led sessions is something you can watch. virtually. So this is the post that my colleague had made for today's Isaac ROS office hours, just talking about object detection with YOLOv8. And this is exactly what we had intended by making these posts on the forum. So thank you, Navier, for your question. What our intention was by making these posts is that before we actually conduct the office hours, like before this 1 hour on Wednesdays, we could already have some questions rolling in on the post. That also helps us better prepare for like what to talk about and what you are interested in learning. And it also helps other people, other viewers who may be watching, learn from questions that developers have out there. So thank you for your question. What I'm going to do is go through this like live, answer your question on the forum itself, like on this post. So let me read out the first question. It says, I'm looking for advice on, let's see. I think this is more segmentation related. So question 1 is, what are the recommended approaches for tracking? Oh, it's object tracking. What are the recommended approaches for tracking multiple objects of the same class across successive frames, considering the dynamics of the scene and potential occlusions? So I think over here, YOLOv8, the official like Ultra Analytics project, does provide like a tracking mode. So from that tracking mode, you can it should work with detection or with segmentation as well, with pose estimation, I suppose. But that tracking mode is something I'd encourage you to check out. Again, it's not something I have tried with the Isaac ROS YOLOv8 node, but if it's something that needs to be wrapped like in a ROS2 package, then of course that's something you can do. Considering dynamics of the scene and potential occlusions. So here we do not retrain, or Isaac ROS does not like fine tune the model in any way. So I guess however best YOLOv8 itself performs on occlusions and on like potential on different scene dynamics is how you would see it work in ROS as well. Second question says, how can I efficiently store, update, and retrieve information about each detected object, especially when dealing with a large number of instances? So I think this becomes a more design question specific to your particular setup. I'm not sure if like whether at the ROS level or at the Isaac ROS level we share a particular way of doing this. But it's something I will find out, and if I do find out an example or something, I will share it on this question on the post over here. But I think some standard things to look at would probably just be like pickle or cpickle files, JSON files, dictionaries. So hash maps. These are very standard, probably not the answer you're looking for, but that would be one way to look at it. And then think about how you can make it ROS if there's a need for doing that. I think questions 3 and 4. Are there any specific tools or techniques within the Isaac SDK or ROS ecosystem to facilitate object management? And question 4, can you share insights or examples on integrating these object management strategies with the YOLOv8 detector? These are great questions. It's something I will have to find out, test, and get back to you about. Maybe write an example myself and then share that as well on the GitHub. But at the moment, I do not know if we have any such object management strategies that are included as part of Isaac ROS. So I think we have some more questions and some more time as well from the same developer. It asks about the difference between TensorRT and Triton when using YOLOv8. So this is something I had mentioned I would come back to. Great question. So TensorRT is optimized, or rather it optimizes to run on the particular hardware, and it uses TensorRT as the backend only. Whereas the Triton node kind of supports multiple different inference backends. So you could use, I believe, Onyx runtime with Triton. You can use TensorRT, of course. You can use TensorFlow and PyTorch. So it's just a little more flexible as to what you can use as the backend. But as far as we've done some benchmarking, and from that, at least the performance between the TensorRT node and the Triton node using the TensorRT backend is almost the same. So for that particular use case, you can use either and it would be the same. And we do have some more information about each of these nodes on the Isaac ROS DNN documentation site. So DNN is deep neural network inference. So if you look at the package, that particular package will give you some more information about these two types. There's a question that says, how can we benefit from int8 optimization? So how you would do this is, First of all, when you pass an Onyx file into the TensorRT node, at that point, it's going to only give you two options. One is FP16 and FP32 by setting that enable FP16 flag that we talked about. But instead of Onyx, what you could do is pass like a pre-generated TensorRT engine file that is intate optimized, and then the rest of like the TensorRT node will just run intate optimized inference. But now the question here is, okay, how do you generate that first intate optimized engine file, right, in the first place? So how you can do that is there is a command called trt-exec, and I will share a link to an example that uses this command. So if you use the trt-exec command, it's just directly using TensorRT on your platform. But over there, you can kind of specify an argument saying int8. And then in that case, trt-exec will first generate an int8 optimized model from your Onyx model. And then once that optimized engine, TensorRT engine, is generated, you can just pass that straight into the TensorRT node. And then that is how you will benefit from int8 optimization. Let me actually go ahead and share a link to that right now. Give me a second. Sharing my screen again so that everyone can see the question. Okay. And I'm sharing a link as well, link to using int8 optimization. I just shared a link in the chat. It says link to int8 optimization, and it's a link to another Isaac ROS package on the documentation side called Isaac ROS by 3D. So this is actually the depth segmentation or proximity segmentation node that my colleague talked about in the last Isaac ROS office hours. If you go to step 7, I believe, of the quick start in the link that I just shared, you will see how to use the trt-exec command to convert into an int8 optimized TensorRT engine file. So that is how you would benefit from int8 optimization in this particular case. Let's see. So the next question says, one more thing. I will be posting a more detailed answer to this question on the post as well. So for anyone interested, please keep following up on this particular post. The next question says, whenever we kill the TensorRT node, there is some information displayed about job statistics or similar that tell us the inference times showing median, 90%, max. Could we go over what each of these parameters show and how to benchmark? So these are, let's take these as two different questions. First would just be what these metrics are, and the second would be how to benchmark YOLOv8 model. So I'm going to enlarge this image. I'm still not sure how clear that is, but you can just see some numbers about like a median, 90%, max, load, exec times for sync and for inference for stream. Now, to be honest, these are not things that are added by any of the Isaac ROS level layers. So the Isaac ROS package itself is not adding this information, but in fact, this information, these numbers are coming directly from the TensorRT part. So the TensorRT node or what's running in the backend. So I do not have much information about what these mean, like off the top of my head. But a good place, I think, would, or the most correct place to learn more would be the TensorRT documentation itself. So over there, you should be able to get more information about these particular numbers. But know that these are not something that's added by Isaac ROS, or it's not the Isaac ROS benchmarking numbers, it's just TensorRT running in the backend. But the second part of the question was, how do you benchmark specific YOLO models we are running? So the reason, like this is a good question, but what you would use here is Isaac ROS benchmark, and I'll share a link in the chat for that. But Isaac ROS benchmark is the right place. You have already we have multiple like pre-existing files that can help benchmark the different Isaac ROS nodes that exist. And you could write one for YOLOv8 or for your specific model in pretty much the same way. So you would use those scripts as a template. And that will give you more metrics about like the latency, throughput, things like that for YOLOv8. And for the Isaac ROS YOLOv8 node alone, but also for like if you want to create a bigger pipeline of, say, like something coming before TensorRT, before inference, and after as well, you can add that entire pipeline in the benchmarking script as well. Let me go ahead and share a link to that now. Let's see. I'll also go ahead. We have a couple of minutes. I'll share the Isaac ROS benchmark documentation as well. Okay, I hope you can see this. So this is the Isaac ROS benchmark repository and or documentation. I've also shared a link for it in the chat right now. This would be a good place to, first of all, learn about how it all works, how it uses ROS2 benchmark to, it's inspired from ROS2 benchmark to actually create pipelines of nodes and perform these particular benchmarking results. Now, what's important to know here is that, let me try sharing a script. Let's go through the quick start. Yeah, what's important to know here is that we already have some existing scripts. But if you see something that does not exist, but you want to benchmark for that particular thing, you can use these as a template, create your own script as well. Let's see. Right. So two things here. You have something called the monitor node and the playback node for Nitrous specific if you're benchmarking. You can use these to kind of constantly publish input messages to your pipeline or to your particular node that's under test. And you have something that will then monitor at what rate output messages are coming from the inference or the decoding or whatever node that you're benchmarking. So you would want to implement like a similar architecture to benchmark your own YOLOv8 models as well. Let's go back to the documentation. We do not have much time left, about 2 minutes. So feel free at this point to post any final questions that you may have in the chat. We have a minute to pick them up. For any questions that may have been unanswered or that you need more detail about, feel free to post it on our forum as well, or the Isaac ROS officers website that we have. Okay. This is just some more information about Isaac ROS benchmark. For example, you have a script, you can just launch the test for Isaac ROS April tag node over here, but you would write something similar for your own test. Let me go ahead and share a link to our Isaac ROS officers questions. Okay, one last thing to share. Okay, I hope you can see my screen clearly. And I also shared a link for this in the chat. These are the Isaac ROS office hours questions page. This is kind of for any questions that may have been pending in the office hours or that specifically you would want to hear us talk about in the next office hours. It's just a very easy form, really. You can just give your question, what topic it is related to, whether it's Isaac ROS or Isaac Sim. And because we have alternating office hours, 1 week we have Isaac Sim and the next we have Isaac ROS, this is the best way to make sure that we get our eyes on all of your questions and that we are prepared in a good way to answer them as well. So feel free to head on over there, post your questions, let us know whether it's for Isaac ROS or Isaac Sim, and we will get to it in the relevant office hours. Okay, so I think time is up. Thank you so much again for joining. If you have any more questions, forum is the right place to go, or the page that I'm sharing right now. And we will get your questions in the next Isaac ROS office hours as well. Thanks for joining, everyone, and have a good rest of the day.